All right. So you'll see on the first slide there's the link to the notes if anyone wants to go ahead and click there and add your name, contact information, but just to share any tips or notes that you want to share with us or each other throughout the session, feel free to do that. And now I will introduce you all to Keith Howard, who's been quiet thus far. Maybe he could tell us about himself.
I'm letting you run it. Good morning, everyone. Thank you for joining us. Glad to meet you. Did we go through and meet everyone? Because I don't know that everyone introduced themselves.
I think we have Alana left, but Alana, if you don't want to jump in, if you want to type in the chat and introduce yourself, you could feel free to do that too. But I think we did have one.
Okay.
I'm actually really impressed you said my name correctly.
Oh. I'm glad I said it correctly.
I'm a middle and high school math teacher at Belgrade Brutnell Rosa, a rural district in Midwest Minnesota.
Okay, nice to meet you.
Okay, glad to see the secondary and particularly middle school folks in the house, because that was my background before getting to higher ed. The slide you see, excuse me, you can see who we are, and we come to computer science from sort of a little bit different places, in that Nicole's experience has been in terms of computer science in elementary school, and mine mostly in secondary. Previous, obviously mentioned, teacher with LA Unified. And we also have recently released a book addressing K-5 computer science, or coding and math, and the integration of math and computer science. And again, my own background was as an algebra and computer science teacher, so was involved in doing that kind of integration early on. And obviously, Nicole, in the elementary area, you would be teaching both, so integration became a part of what you did. These are just some areas listed on the screen, some areas that we do address, not just in the book, but what we would like to have some of the discussion center around today. And just to go over a few of them, there's debate over whether computer science is a core subject area or should be a core subject area. What do we do, or what are we doing it for? What is our purpose? Is it to prepare future programmers? Is it a mode of self-expression? Is it all of the above? Foundational information. I know in our previous sessions, there was a lot of mention of teachers and trying to get teachers up to speed and students up to speed in terms of foundation to get deeply involved in computer science. And then how do we integrate coding into mathematics, or coding or math into our coding as well. So I want to talk about ways of doing that, and we do have some examples obviously in the book, but there are examples. There's a website that will refer you to that with or without the book, you have some examples of lessons, of ways to integrate mathematics. But we also want to hear from you guys. We want to find out from you what kind of ways you might use to integrate mathematics, and what suggestions you have, what successes you've had in that regard. I don't know, Nick, do you want to pick up from there?
Yes, I'm still working on some technical things here, but that's okay. I'll jump right in. And so our next slide, you'll see where we have the tips, examples, and resources. And so these are just some other things that we've thought about, especially thinking of like the lower grades, of course, because our pre-service teachers, that's the context that I'm in right now, where I'm preparing teachers to teach elementary school and high school too. But when I'm working with those future elementary teachers, it's trying to figure out how to present the integration of computer science to them in a way where they can have clarity of purpose, right? What is their purpose once they actually get into a classroom with students? How do they make time to integrate computer science into this full day when there is no standalone computer science course. So that's something that has been a challenge. And then we have the next point, which I'll let Keith talk a little bit more about, the concepts over platforms or devices.
Yeah, so that's a kind of a big one in K-12. We work with districts who want advice or ask us in terms of ways to integrate computer science into their curriculum. And often they buy into a platform or they spend a lot of money on devices because someone told them it can do a lot of things. And we really try and get them to center on the concepts of computer science, the stuff that endures, right? And so if you learn concepts, regarding anything, much of what's regarded, what's covered in coding, whether it be variables, whether it be loops or conditionals, those kinds of things, it doesn't matter what language you end up learning in later, you've benefited from it. That's not often the case when you get involved in some of the devices or some of the platforms that are proprietary, that have language of their own, that have ways of operating, even interfaces that don't look like what we tend to see in computer science. And so there's that, and there's also, and I hope we have some discussion. I hope you guys have some perspectives on it, on that point of purpose. Why are we doing this, right? Because if we're doing it to prepare computer scientists of the future or computer programmers of the future, we would argue that looks different from if you're doing this just so people get exposure to something that they might be interested in later, but you don't want to get too deeply involved in it. Some of the questions around, even at the high school level, sometimes there's the debate over, are we supposed to be preparing our students for high school? Are we supposed to be preparing them for the kinds of computer science they're going to face when they get to high school? And if that's the case, what we do in K-5 may look different. It may look different because we're thinking the long game as opposed to what makes them happy or excited or gets them engaged now. We might do something different. So.
And so we have some other points here on this slide, and as you can see just already, we can have a long conversation on many of the ways in which we can approach the integration of coding and computer science, but we do want to have a conversation with you. And so if it's okay, I'll go ahead and move on. We just would love for you to have a look at some of these other resources, and then hopefully this will also encourage some further conversation. But I'd like to take us to our first question, which is that we added a question. You probably noticed in your prior session, you probably jumped right into what are the greatest challenges or the biggest successes thus far. We'd also like to talk about how you all are currently integrating math into computer science or into coding activities, and maybe start there and then go into, what are some of the successes and challenges in doing so. Anyone having, oh, let's see, look at that. Let me go back. Anyone currently integrating math into computer science? I heard there were a couple of math and computer science educators here.
I have done a little bit. I think one of the challenges has been having a common language or platform to use with students. So this idea of do you have to teach them to use Scratch first before they can use Scratch in math class to develop a program that could find the area of a hexagon or something like that. So that's been one of the challenges, but it's definitely possible, but it's just finding that common platform that all students have access to.
Keith, did you want to respond to that, or?
Yeah, that's one of those things that comes up often when you talk about integrating math. Before you can integrate two subject areas, you need to have some level of competency in each of those areas. And you can find, I'm sure you found, Katie, that when you do that, when you're teaching them the language first, or before you start integrating, then when you go to integrating, you find out some students are having difficulty because they don't understand the math, others are having difficulty because they don't understand the programming, and you don't know which is which. And so how then do you go in and help those students understand what's going on? So that's I would, you know, I'm going to try and hold back in terms of sort of putting my own perspectives on some of this stuff. But in reality, that's one of my arguments for teaching coding or teaching computer science and bringing the math into it in sort of a project-based approach, because then the math, right, is relevant, right? It's not done in isolation in some sort of abstract or not applicable manner. That if you do it to solve a problem within your programming environment, within your programming task, then I would argue it makes the math more meaningful and helps them in terms of understanding, you know, how they code and bring other subject areas in. Anyone else have any experience in integrating math and computer science?
For me, I do not think that I like consciously integrating math into the coding activity specifically, as I'm teaching, for example, computer science A course. But for those students realizing, hey, you know, there's math involved in there for us to make the code runs. And when they say, for example, as simple as math sequence, and they notice how easy it is to use coding to actually generate the sequence, find the sum and stuff like that, it is a rewarding experience. I think one of the challenge that I have in terms of math is when the students trying to understand or using mod, and which is very rarely being taught in, you know, high school math or even middle school math, you know, to generate options or loops, or when we're doing coding. So I think the challenges that we have in our school is just making sure that students have at least maybe finished a certain math course before they join a certain coding class. I think, like, for example, computer science principles may not need as high or as much exposure in math as when you're doing coding with Java or computer science A.
Yeah, two things there. I think the piece about computer science A, as actually computer science principles versus computer science A, that's a debate that that a lot of teachers are having, and quite honestly, folks in higher ed are having, because our computer science faculty indicate to us that they have no idea what they're getting from the students that go through computer science A. There's so much latitude in terms of what they're doing in those courses. So they don't have the confidence there. In fact, they've even created courses to work directly with some of the high school students before they get to the university, because they're afraid they're not getting the preparation from principals that they could. And I understand the purpose of that really was to bring more people into the fold. The other piece is you're talking about, I'm going to paraphrase sort of, you don't know if you're really, or you're doing it a little bit in terms of integrating the math with the computer science. I think what you described is exactly how I would suggest that it gets done, is that you bring it in, and even though they recognize that, oh yes, I'm using some math to do this program, that's how you do it. You find the ways where it's necessary. As a prior algebra teacher, I always dealt with the obstacle of trying to explain to kids where you use algebra in your life, right? They used to, Mr. Howard, how do you use algebra in your life? And we often offered them sort of this utility value, suggesting you needed to get into college. Well, that isn't necessarily the best answer, right? I need it for more than that. If you want me to invest my time and energy and really learn this stuff, I want to find out where it's actually applicable. So I think you provide some avenues that sort of start to answer that question for them. You need to understand the mathematics that support a program that you're making. It makes more sense to them.
I'd like to Oh, yes, please. I was just going to ask a follow-up question, but jump in.
Okay. And it's not related to the previous one.
Okay.
Oh, you're recording. Okay. Nicole, I just want to thank you. My husband's facilitating one of the sessions, so I'm going to move over here.
Okay.
I just want to thank you for including early elementary. So I'm coming at it from a different perspective, not as like things in silos, like here's computer science, here's math, but I'm wondering the opposite is how to integrate computer science into math, because in elementary, our focus is so much on reading and math. I teach first grade, but I'm a former engineer and math is my favorite thing to teach. And so I'm just wondering the opposite, how to integrate computer science into math. And I'm part of the code savvy cohort, so just starting in this whole process. So anything you could advise for that would be great.
Yeah, I mean, I definitely can give some tips there, and I would I think that's also just to add to why this is a powerful group, because this is one thing that we don't do often, is bring elementary educators into a space with our secondary educators and talking. We just gave you an example of what university professors say that they feel they have to do, what they need to do to support high school students. And so I would even ask some of our educators here who are secondary, what would be some of the things you would like to see from students who are moving from elementary and coming into middle school? You know, what are the gaps? And that would even help us think about, you know, how do we bring this content even in a more engaging way to students, but how do we make sure we're preparing elementary students for that transition? So I'd love to even open that question up to others too, to see if they have any tips or ideas about how to, or what tools might you be using for students who are new to computer science, who are in your math classes and you want to introduce math concepts and computer science concepts to them.
I work with kids that are slightly older. My youngest are probably in 7th grade or so. But one of the things that we've found that I can use in my math classes to integrate CS occasionally is some of the CS Unplugged activities lend themselves really nicely to that. So we do like a which one doesn't belong 2 or 3 times a week. And you can make those topics really easily kind of bounce between the subjects. Yeah.
Yeah, that's a great suggestion. And then I just moved us over to a slide we put at the end of our deck, just in case, you know, we didn't want to, you know, push a conversation in a direction we weren't ready to explore. But I know this is one thing that, and I'll let Keith speak to this specifically, but we talked about sort of, you know, this idea that we do a lot of the drag and drop with our elementary students and how it's beneficial, you know, as an entry point perhaps, but then at what point do we introduce a little bit more so that they are prepared when they move into middle school and in high school? So Keith, did you want to talk about Flogorithm or any of the ways in which maybe we link operations to coding, et cetera?
Yeah, sure. I do want to mention though, on the elementary side, that even from our work with some of the vendors who produce different programs, we as researchers always ask for the research. We ask for the sort of what documents the efficacy or the effectiveness of your program. And I would encourage you to do that with anyone who's presenting something to you to be used with your students. Where is the evidence? And particularly since we do a lot of drag and drop, we do a lot of block coding, they will tell you, if you ask them, they will tell you that the research is not there that provides support that this drag and drop, this block coding, one, does it generate more interest in terms of STEM subjects or programming later on? 2, does it prepare them for programming in a professional programming environment? You can see at the bottom right of the screen, you've got coding, you've got basically identical coding, Scratch on one, and Visual Studio, which is one of these platforms that allows you to, it's a development platform that allows you to program. It's the tool that they use in the professional environment. You can get it for free. There's a community version, and learning that puts them in the tool that they would be using in a real programming environment, and actually can create programs for different operating systems.
Mm.
And so there's that question we have to ask, is drag and drop, is that what we should be doing? Is there evidence that that's going to get us where we want to go? Over on the left is a flowchart based program. It's a Flogorithm, and it was developed by folks at Sacramento, I think Sacramento State. It can connect to some of the unplugged activities like flowchart-based programming. Only this does it obviously on a. This is a PC-based program. You download it, again, it's free, and it allows you to concentrate on the flow of programs in a way that's different from some of the drag and drop, in that you have to think through the flow of the program like you would if you were programming in a text-based program. But either of those environments provide something different. And I would hope that we would become open to some different types of ways of preparing students for computer science, because real quickly, part of that is based upon what you think is the purpose, right? Again, if the purpose is preparing them for what they're going to do in high school, ultimately CSA is going to give them something more similar to what you see in Visual Studio than what you see in Scratch.
I see really great questions coming up in the chat. And Zach, I appreciate your responses to some of these too. Is it Taryn or Taran? Okay. She's asking, her students are so young in some cases where maybe they're not reading yet. And so she's asking about, so I mentioned the colors, right? So the unplugged activities that Zach mentioned are really helpful. Even teaching color association with those blocks to teach pattern, even having them do patterns and teaching them the colors for movement of the blocks is helpful because they recognize the colors. Scratch Junior was mentioned. There's another question though. In the flow system, would you teach that a shape correlates to a function?
Actually, it does. The program actually has some connections to that kind of approach as well. In fact, you can download different color themes for what they use there. In fact, there's a Mario Brothers color theme. It's linked to some things that the students already have some connection with. I think there's a Minecraft too, if I'm not mistaken, but it connects. So you would just download a theme and then it would change all of the colors. The shapes are similar to what, if you've been around from programming days when we used to do the flow charts, that the shapes, all except for I think 2 of them, are what were represented earlier in terms of flow charting. I started off that way in terms of doing that and feeding it into a computer. But it sort of has the same, process in terms of teaching flow of a computer program, and it does it in sort of a different way visually than a stack, right? Stacking things, and then even when you do the drag and drop, there is some embedded functionality in you really are insulating the students from the code in drag and drop. And I don't get me wrong, I'm not arguing that this is no good, that you should never use this kind of thing. I'm not going to argue that at all. I think we're still trying to figure out what's going to work in the long run.
And this is what I used in my classrooms when I was teaching in elementary classrooms. I used the block coding. I think what we're more thinking about, and just to take us on to a couple questions. First, there's some questions in the chat I do want to get to, but I want to take us back to that one question about it's second from the bottom, how might we broaden participation from underrepresented groups to this topic? And so when we think of underrepresented groups, we can think of, race, disability, we can think of socioeconomic status. So we think about different things and the ways in which students don't have access to what they need. And so it could be about literacy, as you mentioned. So we need to use block coding when it's appropriate in order to support in building the literacy that's necessary. So we're definitely not saying don't use it at all. We're saying, at what moment do we think about purpose and make the shift to transition to the next level for students? So there are some great resources being dropped. I'm trying to also take us to a question about, if I go back up here, Keith, curious what you have to say about Joe Boyler's efforts to make a data science alternative pathway in California's secondary math. Have you seen enthusiasm from colleagues or former colleagues on that front?
Haven't seen enthusiasm, but it brings enthusiasm to me. Anything having to do with data gets me motivated. Look, I teach statistics, right, at the university. So anytime you bring in data, I think we're overall, we're trying to figure out, be honest with you, in this country, we're trying to figure out what it is we're doing with computer science. Again, it's like, it's similar to when we first started bringing computers into the classroom. We knew we wanted to spend a lot of money and bring a lot of computers into the classroom, but we didn't quite know what to do with them. And we started with labs, we separated them to individual classrooms, but we didn't really have a plan for it. And the same is true for computer science, partly because there's so much variety out there in terms of tools, in terms of approaches, platforms, and we haven't agreed on any particular approach to it. There are several movements around the country that have to do with bringing more computer science, make it a math subject, make it a required subject. I don't know, and from a discussion with one of our local districts, we were having a discussion over whether or not it should be a core subject. I don't know if I agree with that. If you're using the approach that it's to prepare folks, computer science is to prepare folks to be programmers, because everybody doesn't want to be a programmer, right? And if everybody doesn't want to be a programmer, if some folks want to, maybe dabble in programming but don't necessarily want to be a programmer, then maybe your approach is different for that student than it is for someone who says, you know what, I really like this, I'd like to make a career out of this, and I want you to prepare me in that regard. I think we have to be flexible in that regard, but a lot of it depends on purpose, and from my perspective, we haven't figured out what we want to do yet. I have ideas. If it were up to me, I'd make it a certain way, but I know I have to recognize that people have different perspectives that we have to honor in an education, in a democratic education environment.
So is there anyone else who wants to jump in? Like, you've been thinking something this whole time and you've wanted to jump in and share it, and you've been listening, taking it all in. We'd love to hear from you. I think we have 2 minutes before we move back into our main session. Time flew by.
I guess I would say that, like, when I'm working with my pre-service teachers, I teach math. Sorry, I didn't introduce myself at the beginning. I think that thinking about coding or computing outside of just coding is important too. Just getting used to technology and using, say, a geometry visualization dynamic system can be really helpful for mathematics. Even though you might not think of it as line by line programming, you're still getting that idea of a logical sequence. And I think that can really free people up to call using computing in K through 6 something different other than just focusing on specific line by line programming.
Yeah, I agree 100%. Yeah, I no objections to that. I think there are a number of different ways that you can bring types of technology or computing or understanding math and integrating. I think there's a number of ways to do it. And I think that it goes to I think the point I was making earlier. You can't sort of one size fits all this. You can attempt to one size fits all algebra or learning the specifics of language, but when you get into computer science, it goes into so many different sort of strands that are important. You think about robotics, right? That's a different approach. You spend a lot of money and a lot of resources on robotics. I've seen some research, though, I think coming out of Colorado, that the jobs, the number of jobs related to robotics is nowhere near the investment that we're putting into it. That there are some jobs there, but there's not a whole lot, and maybe we're putting more emphasis on that because kids like to do it, rather than it's something that we have a need for as a society. So a lot of things have to be considered. Appreciate the comment.
Well, thank you all for your time today. I wish we had more time together to hear from more of you. You know, this is a great conversation. If you can add your information, if you want, to the shared notes doc, I just dropped the link again in the chat. That would be great. And any other resources you'd like to share, we'll try to grab some of these links from the chat box and put them onto that doc too. And we look forward to seeing you guys back in the main session.
Thanks,
everyone.
Thank you for your participation. Appreciate the comments and feedback. Thank you.